So in the last lecture, I talked about the work of Thomas Kuhn, in particular the material which is often referred to as his moderate material. And in this lecture, I'm going to be talking more about his more radical claims. In case you missed the last lecture, a really quick recap of what moderate Kuhn says. Moderate Kuhn challenges the Enlightenment idea that the history of science progresses through sort of this linear progression of more and more knowledge, more and more information, getting closer and closer towards truth. Rather than a linear progress, science undergoes various revolutions over time, which starts with a sort of disorganized period known as immature or pre-paradigm science, and then gradually over time a paradigm develops, and that organizes things and makes scientific investigation more structured and more powerful, and that leads to long periods of what he calls normal science, which is science that's governed by a paradigm. And normal science is very regular and very predictable, and it consists mostly of people going into the lab or into the field and governing their experiments based on what the paradigm says they should expect. Over time, anomalies accumulate. Most of the time, they're discarded. They're sometimes resolved later. But over time, some anomalies that can't be dissolved end up accumulating. This ultimately leads to a phase known as crisis science. And then that leads to a paradigm shift, which brings about the new paradigm. And then we return to normal science, going back to doing everyday science in the lab or in the field. Now, like I say, some of the details are debatable, but on the whole, this is not terribly controversial stuff. In this lecture, what I'm going to be looking at is the radical claims of Thomas Kuhn. One of the ideas that's radical that Kuhn suggests is that having a scientific a paradigm shift is more like having a religious conversion, or another analogy he uses is a change of one political party to another, or another analogy still, deciding that your favorite flavor of ice cream is a different flavor than it was in the past. None of these things are rational processes that are governed by evidence or experimentation or anything like that. It's more of a sort of a personal shift. It's something that sort of transforms the way you look at the world. And he, stealing an idea from psychology, perceptual psychology, he invokes the idea of a Gestalt shift. A Gestalt shift being a total change in perspective that eliminates the old perspective. You can no longer see the world the way you once did once you have that Gestalt shift. And a Gestalt shift is not driven by evidence or by scientific reasons or even arguably by any sort of rational reason. There's no rational reason or scientific reason or evidential reason to prefer one perspective on the Gestalt rather than the other. The choice is made for what you might call personal reasons. Now, I've showed this picture here before, the picture of the old woman and the young lady, and this is an excellent example of a Gestalt shift. What is this a picture of? Well, it's not a picture of only a young woman or an old lady, but you really can only see it as one or the other at a given time. You might be able to shift back and forth between the two, but at any given instant, you either see the old woman or you see the old lady. You can't see both at the same time. And it's not like there's anything in the picture itself that dictates whether or not you see an old woman or an old lady. You can actually push this entirely by priming. If I tell you I'm going to show you a picture of an old lady and then show you this picture, you'll almost certainly see the picture of the old lady first. If I tell you it's going to be a young woman, you'll almost certainly see the old woman first. So what you see this as is not determined by the picture itself, but rather determined by the context in which you see the picture. Facts about you rather than about the data itself. And that's what Kuhn is saying is the case of science. When we're in the middle of a crisis science, everyone's looking at the same evidence, but some people are seeing it in terms of one paradigm, the old lady, and other people are seeing it in terms of the other paradigm, the young woman. Here's another picture. This is the famous Necker cube, which many of you have no doubt seen before. It's a two-dimensional picture, of course, but our brain sort of automatically interprets it as a three-dimensional image. And one of the awesome things about the Necker cube is you can see it in at least two different ways. On one way, this box that I'm tracing right here with my cursor now, that's closest to you, and it's descending back into the distance right there, and that box right there is sort of on the far end. That's sort of one vision of the Necker cube. And the other one, you're looking down on top of the box, and this box right here that I'm tracing with my cursor now, that's sort of on the top, and this line here is descending down closer to the Earth, and then the bottom part of the cube is right there. Now, there's also, of course, a couple other ways you can actually visualize the cube, but those two are the most important ones for my purposes right here. Once you see the different cubes, you can sort of will yourself to switch back and forth between them. But there's nothing in the picture itself that dictates you see the cube this way rather than that way. And I hope the metaphor here is clear. Kuhn says that when you are in the middle of a crisis science state, the Enlightenment picture says, well, you just look at the data and you follow the data where it leads. But the data is ambiguous between the paradigms. The data it does not settle the issue over which paradigm it is going to be preferable, at least not by itself. Instead, it's issues about the observer. It's facts about the people who are making the determination as to which is the better paradigm that's ultimately going to dictate which paradigm is best and which paradigm is to be discarded. So what this leads Kuhn to suggesting is that we can't rationally choose between paradigms because the subject matter, the data, is conceived of in drastically different ways between the two paradigms, and you cannot compare the way that the data in terms of a single context. The two competing paradigms will tell you how you ought to interpret the data, and that means that there is no paradigm-independent way of seeing which is objectively better. The Enlightenment picture says that there's some sort of method that you can use to determine which one is superior, but the methods are determined entirely by the paradigm. What is a good method according to one paradigm will be a bad method according to another, and the whole point is we're trying to decide between paradigms. It would be question-begging to say, well, according to this paradigm, this is the best way to see the data, so therefore that's how we ought to see the data, because the other paradigm is going to say, well, according to this paradigm, we should see it that way, and so therefore that is going to be the way it is. And that's what makes the state of crisis science a crisis. Because unlike in normal science, where you know exactly what to do, you know exactly what procedures to follow to get what you want to solve your puzzles, in crisis science, there is no clear-cut procedure. There is no set of rules that you can follow to resolve the crisis. So what he says then is that the paradigms are incommensurable. That's one of the key words he uses. They're incommensurable. We have the phrase, we speak of apples and oranges. I've never really liked that phrase very much myself. It seems to me that apples and oranges are quite commensurable. You can compare them in any number of metrics. You can compare them based on size. You can compare them based on tartness or sweetness. You can compare them based on color. And of course, they are both fruits. So I don't really particularly myself like the phrase apples and oranges, but it's a common enough phrase, so I'm going to use it here. To say that paradigms are incommensurable means that there's no metric upon which you can compare them in a purely objective, purely rational, purely scientific way, because it's the paradigm that determines what is rational. It's the paradigms that determines what counts as good science or bad science. So it might help, obviously, if we point to some particular examples of incommensurability here. Think, for example, about the term mass and what the term mass means in a Newtonian context versus what it means for someone like Albert Einstein. Now, for Isaac Newton, the term mass is something that has a constant, absolute meaning. It does not matter what you're referencing it to. It doesn't matter what your framework is. It doesn't matter how fast it's going. Mass is a property of the thing itself and nothing but the thing itself. But according to Albert Einstein, mass is actually relative to your framework. The closer you get to the speed of light, the more your mass increases. This is why, for example, in the Large Hadron Collider and other particle accelerators, it requires an awful lot of energy to accelerate these particles because we're getting them to very, very close to the speed of light. And the closer they get to the speed of light, the more massive they get, and hence the more energy that we need to accelerate it even further. We have two paradigms using the same term, the term mass, but the term means something completely different for one paradigm than it does for the other. And this creates confusion. Kuhn makes an analogy to foreign languages. Oftentimes, two different languages will have the same term, the same 4 or 5 letter sequence, but those terms will mean something completely different in one language than they mean in another. So even though they're using two different languages are using the same term, they mean radically different things. And the same thing is true of paradigms, Kuhn says. The word mass, even though it's the same 4 letters, M-A-S-S in English, it means something completely different for Einstein than it does for Newton. They are, even though they're using the same term, they're not talking about the same thing. It might look like they're talking about the same thing because there's something similar about what they're saying. They're both talking about something vaguely connected, but they are defined in completely different ways by their different paradigms. And there's no sort of common language that Newton and Einstein can both appeal to settle the dispute because the meanings of the words are sort of isolated to the paradigms. Even though scientists are trying to communicate with one another in the midst of the crisis between Newton and Einstein, they're trying to talk the same language. They're actually failing to do that because they are using different languages. And it's not just the language that differs. It's also what counts as evidence, what counts as good evidence, what counts as a legitimate test of a theory or a hypothesis will vary from one paradigm to another. All of these things are paradigm dependent, and there is no paradigm independent way of testing which of these paradigms is going to be superior. Another example might help here. Think about the question of whether or not scientific theories should explain. This, for a long time, was a huge controversy. Now, in a later lecture, I will talk about the nature of explanation in the context of the philosophy of science. But one of the big problems that Newton's theory of gravity had at the time was that it was unable to explain why objects attract each other. It gave a mathematically very accurate description of the attraction, but there was no mechanism, there was no context in which explained why it is that these objects were attracting one another. There was a competing theory at the time, which came from René Descartes, who was a rough contemporary of Newton's. And Descartes had a theory of gravity, and it provided an excellent explanation about why objects attract each other. It actually wasn't, oddly enough, it's not too dissimilar from the explanation ultimately that Einstein would give. Descartes compared space to water in a bathtub, and just as when water in a bathtub goes down a drain, things would rotate around going down in the drain. He said that's kind of like what gravity is. There was sort of a comprehensible explanation for Descartes' theory, but the problem is he had really no method to calculate that attraction. So what we have here is two competing values which favor one paradigm versus another. There's a real question here. What should be more important in the context of science, explanation or accuracy? And Kuhn says there really is no paradigm-independent answer to that. It's really going to depend on your point of view. In some contexts, explanation will be more important than accuracy. In other contexts, accuracy will be more important than explanation. And what's going to determine that context is going to be the paradigm that you've adopted. In the Newtonian paradigm, accuracy mattered more than explanation. But in the Cartesian paradigm, explanation mattered more than accuracy. It wasn't science that dictated that Newton was right and that accuracy was more important. There was nothing about the data or the evidence itself that's favored Newton over Descartes here. It was a value judgment of the scientists at the time. They said, given how incredibly powerful and how useful Newton's mathematical formulation is, we're going to go with that one on the basis that we care more about accuracy of prediction than we do about explanation. And again, if you think about things like warfare and cannonballs and that sort of stuff, then ultimately, of course, in things like the space program, you see why that's going to be much more useful in a pragmatic sense than Descartes' theory would ever have been. It makes sense in many ways to sacrifice the explanation in favor of that kind of pragmatic power. But that pragmatic power is a human value. It's not something that's built into the data itself. So while Newton's paradigm won this debate, then for about 250 years, physicists just sort of gave up on the idea that we needed to explain gravity at all. They just sort of said, look, we have this incredibly powerful formula, this incredibly powerful calculation, and if you want an explanation, go somewhere else, because science simply isn't in the job of trying to explain things anymore. And it wasn't until Albert Einstein came along that we were able to so to speak, to have our cake and eat it too, to have both an explanation and mathematical calculations that worked hand in hand. Let's set that aside for now, though, because again, that's sort of getting ahead of things, and just sort of see how, in the context of a crisis between Newton and Descartes, how you're not going to have a paradigm-independent way of settling this dispute objectively. Now, this brings us back once more to the theory-ladenness of observation. This is a concept I explored in previous lectures. And the basic idea behind the theory-ladenness of observation is that what you observe is conditioned and mediated, in Kuhnian terms, by the paradigm. The paradigm that you accept will influence, if not determine, what you see and what you don't see. One example of this, again, there's a famous perceptual psychology experiment known as the anomalous playing card experiment, where psychologists will flash the playing cards very fast, and they'll get clever. They mix things up. They will show a spade that's painted red, for example, or a heart that's painted black, and whether or not people see that black heart as a heart or as a spade will depend on how they're primed. And if they're primed in terms of cards, they will see the black heart as a spade instead of as a heart. And Kuhn uses this as an illustration of how when you expect to see something, sometimes you see what you expect to see rather than what's actually there in front of you. And the paradigm, of course, is entirely about managing your expectations and telling you what you should expect to see. Now, how we interpret evidence depends entirely on our paradigm, and there is no paradigm-independent viewpoint that tells us how to interpret those observations. In the context of normal science, most information comes in and is filtered for the paradigm in a sort of perfectly straightforward way. We see exactly what the paradigm says we ought to see. But when we enter the crisis phase, suddenly that becomes far less reliable. Now, a quick side note here, because some of you are probably thinking this. One thing that happens often is that creationists will try to abuse this point by saying things like, well, we all look at the same facts, but we just come to different conclusions because of our presuppositions. I don't know whether or not they are actually familiar with the work of Thomas Kuhn and they're deliberately trying to employ this in their machinations or not. But suffice to say, Thomas Kuhn is not in any way providing fuel for creationists. I won't get into precisely why, but even in his most radical days, Kuhn never had any truck with creationists. He wouldn't have truck with intelligent design either. He is by no means going into that sort of, that to him would be a clear example of something that's ascientific rather than a dispute within science or between paradigms. There is no creationist paradigm. There is no intelligent design paradigm in science, in biology or physics or elsewhere. That does not even rise to the level of what Kuhn would call a paradigm. So in case that's been worrying in the back of your mind, we can set that aside right now. A consequence of the theory-ladenness of observation for Thomas Kuhn is that no amount of evidence can decide between paradigms. The Enlightenment picture says, well, when we're in crisis science and we have two paradigms competing against each other, we should go out and perform more experiments and get more data. But more data is not going to decide between the paradigms because the paradigms will simply interpret or filter that data in a way that protects the paradigm itself. This is a way of saying that the theory is underdetermined by the evidence, or again, in the context of in Kuhnian language, the paradigm is underdetermined by the evidence. This is to say that no matter how much data you have, the evidence will always be compatible with a very wide range of paradigms. Now, to be clear, he's not saying that Popper is completely wrong. Obviously, there may in fact be enough evidence that will rule out certain paradigms, but the evidence will never conclusively rule in only a given paradigm. There's always going to be competing paradigms which are perfectly compatible with all the data that you have, no matter how much data that you have. So this is a bit of a foreshadow to some of the things Kuhn is going to say to try to sort of leaven his radical claims. He actually does not say that there is no experiment that can decide between two paradigms. There may indeed be evidence that favors one paradigm over another, but the thing to note is that you can never have paradigm ruled in completely by data, and that all competing paradigms will always be able to reinterpret anomalous data as mere anomalies, as something that should sort of be discarded or relegated to another discipline, so as to try to defend itself from apparent counterexample. This is leading back to the sort of stuff that we saw in the previous lecture. So at the end of the day, there is sort of no single univocal scientific way, no single scientific method that can decide between paradigms. And what I mean by that is there's no sort of automatic way. There is no sort of procedure that you can follow that is the scientific procedure that's going to dictate how to resolve the dispute between paradigms. Because non-scientific and arguably even non-rational reasons are always going to make a difference. And the thing, though, that often surprises Kuhn is that so many people object to this idea because they think it's going to lead to some sort of chaos in science. But Kuhn thinks the exact opposite is true. Kuhn thinks all of this is a very good thing for science. If there was a single sort of scientific method, a single univocal way of understanding things, science would be in an awful lot of trouble. And to see why, consider yet another analogy that Kuhn makes, the political analogy. Kuhn compares a scientific revolution to a political revolution. Under a given political regime, i.e. under a given scientific paradigm, there are clear standards for what counts as something that's legal versus illegal, and likewise in the context of science, something that is good science and something that is bad science. The regime or the paradigm dictate what is acceptable and what is unacceptable. But when a coup occurs, that is to say, when we're entering into a stage of crisis science, when upstarts try to sort of overthrow the dominant paradigm or the dominant regime, it very quickly becomes unclear what qualifies as legal or illegal. That is to say, what qualifies as good science or bad science, because you don't know how the coup is going to be resolved. It might be the case that the old regime will regain control, in which case actions that arguably would have been legal had the coup succeeded suddenly become illegal. That is to say, things that would have looked like good science from the point of view of the new paradigm. If the new paradigm is shot down, then suddenly that no longer looks like good science, it's bad science. But again, the reverse very well may be true. You can't know which way it's going to go in the middle of the coup. You can't know which way it's going to go in the middle of the crisis, whether the old paradigm or the new paradigm will succeed. If the new paradigm succeeds, then what once counted as good science will now be bad science. And likewise, when the coup occurs, what once counted as something that was legal will now might very well be illegal, because it's what are the rules are dictated fundamentally by the paradigm or by the regime. There is no thing that's just illegal or illegal, period. Laws are always relative to a certain political culture. And likewise, what counts as good science and bad science is always relative to a given paradigm. When a new paradigm usurps the old paradigm, we may transform our vision of what counts as good and bad science. Like I said before, in Aristotle's day, what counted as good science is very, very different than what's going to count as good science in our day. That's not because Aristotle was fundamentally flawed or wrong or stupid or anything like that. It's because his standards for what counts as good science are radically different than our standards for what counts as good science. So when the paradigm is in crisis, there are no such standards for what counts as good or bad science. And that means we can't just go out there and do science, do normal science to resolve these disputes. There's no legal mechanisms that you can appeal to sort of adjudicate a dispute between a competing regime and the coup. The context of a law only makes sense when you have a stable government that is in control. There's no regime-independent way of understanding what is legal and illegal. And likewise, no amount of empirical data or scientific mechanisms can help us choose between paradigms, because science and data only make sense in the context of a paradigm.